Welcome to Study Loop.
Hi, in the given problem, the length of the propeller of airplane is given as L, which is rotating around its center with an angular velocity omega in a magnetic field that is perpendicular to the plane of rotation. And we are modeling the propeller as a thin uniform bar. So we have to find the potential difference between, in the first part, the potential difference which we have to find is between the center and either of the end of the propeller. So this is the center, this is one of the end. Let it be A. So the length of this end from the center will reduce to half of the total length. This is L dash. So as L dash is equal to L by 2, and we know the expression for motional EMF induced is given as half B L square omega. So here it will become half B L by 2 to the whole square times omega, or we can say it becomes 1 by 8 times BL square into omega. This is the EMF induced between the center and one end of this propeller. Now, in the second part, we have to find the EMF induced between both the ends, but as both the ends are having the same potential, so we can say potential difference between them comes out to be 0. Now, in third part of the problem, we have to find the actual value of this EMF induced when the Earth's magnetic field is given as, at that place, it is having a value of 0.50 multiplied by 10 raised to the power minus 4 Tesla. The angular speed, the rate of rotation means frequency of this propeller has been given as 220 revolutions per second, or we can say 220 by 60. This is revolutions per minute, or 220 by 60 revolutions per second. And length of the propeller has been given as 2.0 meter. So EMF induced, as we found in part A, will be reduced to 1 by 8 multiplied by 0.50 multiplied by 10 raised to the power minus 4. Length square means 2 to the whole square. Then for omega, this is given as 2 pi f. So this is 2 into 3.14 into 220 by 60. And all these values come out to be 5.76 into 10 raised to the power minus 4 volt. Or we can say this is 0.576 multiplied by 0.3 volt, or we can say this is 0.58 millivolt. Thank you.